Right now, as you watch this video, our entire galaxy is being pulled through space at 1.4 million miles per hour towards something so massive and so terrifying that scientists refuse to talk about it publicly. The Great Attractor is an invisible gravitational monster that's dragging the Milky Way and over 100,000 other galaxies toward an unknown destination. The most horrifying part? We can't see what's pulling us, and we can't stop it. In the 1970s, astronomers made a discovery that fundamentally changed our understanding of cosmic motion. They found that our galaxy, along with thousands of neighboring galaxies, is moving through space in a coordinated pattern toward a specific region of the universe. This wasn't random drift. It was organized, directed movement on a scale never before imagined. The discovery came from studying the cosmic microwave background radiation, the afterglow of the Big Bang. Scientists expected this radiation to be perfectly uniform in all directions, but they found something disturbing. There was a distinct pattern showing that our entire local group of galaxies is moving at an incredible speed of 1.4 million miles per hour toward a specific point in space. What was pulling us? The answer was something so massive and so distant that it challenged everything astronomers thought they knew about the universe. They named it the Great Attractor, and it represents one of the most terrifying mysteries in cosmology. The Great Attractor is located roughly 250 million light years away in the direction of the constellation Hydra Centaurus. But here's what makes it truly mysterious. We can't see it. The object or region responsible for this massive gravitational pull is hidden behind what astronomers call the Zone of Avoidance, the plane of our own Milky Way galaxy. Our galaxy's dense collection of stars, gas, and dust blocks our view of whatever lies beyond, creating a cosmic blind spot that hides the Great Attractor from direct observation. It's like trying to see through a thick forest. The gravitational effects are undeniable, but the source remains hidden in the cosmic shadows. What we do know is terrifying. The Great Attractor has a mass equivalent to tens of thousands of galaxies like our own. Its gravitational field is so powerful that it's influencing the motion of matter across hundreds of millions of light years of space. We're dealing with a cosmic structure so massive that it operates on scales beyond human comprehension. The Great Attractor isn't just pulling our galaxy. It's orchestrating the movement of the entire local universe. Over 100,000 galaxies in our cosmic neighborhood are all flowing toward this mysterious gravitational center, like water spiraling down a cosmic drain. This coordinated movement is called the Great Attractor flow, and it represents the largest known structure in the observable universe. But here's where it gets even more disturbing. Recent observations have revealed that the Great Attractor itself might be caught in an even larger gravitational current. Something called dark flow appears to be pulling the Great Attractor, along with everything it's already captured, toward an even more distant and mysterious destination beyond the edge of the observable universe. If this cosmic scale gravitational manipulation is blowing your mind like it's blowing mine, absolutely smash that like button. And if you're a smart person who loves uncovering the universe's most terrifying secrets, subscribe so we can explore more cosmic nightmares together. As technology improved, astronomers began to pierce through the Zone of Avoidance using radio telescopes and infrared observations that can see through cosmic dust. What they discovered was even more shocking than they expected. The Great Attractor isn't a single massive object. It's a cosmic megastructure of unprecedented scale. The region contains the Norma cluster, the Centaurus cluster, and dozens of other galaxy clusters all gravitationally bound together in a structure called the Laniakea Supercluster. This cosmic web of interconnected galaxy clusters spans over 500 million light years and contains the mass of 100 million billion suns. Our own Milky Way is just a tiny speck on the outer edge of this cosmic monster. But even this enormous structure can't fully explain the gravitational effects we observe. There must be additional mass, dark matter, hidden galaxy clusters, or something even more exotic, contributing to the Great Attractor's incredible pull. We're being drawn towards something that might be fundamentally different from anything else in the known universe. The Great Attractor represents a crucial node in what cosmologists call the cosmic web, the largest structure in the universe. This web consists of filaments of dark matter and galaxies connected by gravitational bridges spanning billions of light years. The Great Attractor sits at the intersection of several major cosmic filaments, making it a gravitational superhighway junction. This positioning explains why the Great Attractor has such massive influence over galactic motion. It's not just a single massive object. It's a convergence point where multiple streams of cosmic matter flow together. Imagine a cosmic whirlpool where several rivers of galaxies merge, creating a gravitational vortex that captures everything in its vicinity. The truly terrifying implication is that this cosmic web structure might be growing stronger over time. As more galaxies flow along the filaments toward nodes like the Great Attractor, these gravitational centers become even more massive and influential. We might be witnessing the early stages of cosmic collapse on the largest possible scale. Even more disturbing than the Great Attractor itself is the discovery of dark flow, a mysterious cosmic current that appears to be pulling the Great Attractor and everything around it towards something beyond the edge of our observable universe. This suggests that there are structures or forces operating on scales larger than anything we can directly observe. Dark flow indicates that our entire observable universe might be just a small part of something much larger and more complex. Whatever is causing this flow exists beyond the cosmic horizon, the maximum distance we can see due to the finite age and speed of light. We're being pulled towards something that might be fundamentally unknowable with our current technology and physics. The implications are staggering. If dark flow is real, it means that the ultimate fate of our galaxy isn't determined by local gravitational structures like the Great Attractor, but by cosmic forces operating on scales beyond our comprehension. We're passengers on a cosmic ship heading toward a destination we can't see and might not be able to survive. So when will we reach the Great Attractor? The journey is measured in cosmic timescales that dwarf human history. At our current speed of 1.4 million miles per hour, it would take approximately 20 billion years to reach the Great Attractor center. That's longer than the current age of the universe, which means this cosmic collision won't happen for an unimaginably long time. But the journey itself is already affecting our galaxy's fate. The gravitational influence of the Great Attractor is gradually changing the Milky Way's trajectory through space, altering our interactions with neighboring galaxies and potentially affecting the long-term stability of our solar system's orbit within the galaxy. More immediately concerning is what happens to the cosmic structures we encounter along the way. As we move through the gravitational fields of other galaxy clusters being pulled toward the Great Attractor, we might experience cosmic traffic jams, where multiple galaxies converge in the same region of space. The most terrifying aspect of our journey toward the Great Attractor is what happens when we get there. Current models suggest that galaxies flowing into the Great Attractor region don't simply orbit around a central mass. They merge, collide, and eventually form an even larger gravitational structure. This means that billions of years from now, the Milky Way will likely collide with countless other galaxies that are also being pulled toward the Great Attractor. These galactic collisions will trigger massive star formation events, create new black holes, and potentially disrupt the delicate gravitational balance that keeps our solar system stable. Even more disturbing is the possibility that the Great Attractor region might eventually collapse under its own gravity, forming a structure so dense and massive that it creates a cosmic event horizon, a point of no return where not even light can escape. We might be heading toward the formation of a universe-scale black hole. One of the most frustrating aspects of the Great Attractor mystery is that we can't directly observe the very thing that's determining our cosmic fate. The Zone of Avoidance, created by our own galaxy's dust and gas, prevents us from seeing clearly into the Great Attractor region, leaving us to infer its properties from gravitational effects alone. This observational limitation means that our understanding of the Great Attractor is fundamentally incomplete. We know something massive is there, we know it's pulling us, but we don't know exactly what it is or what we'll find when we arrive. It's like being on a ship in dense fog, knowing that you're being pulled towards something enormous, but unable to see what lies ahead. Recent efforts to map the Great Attractor using radio telescopes and infrared observations have revealed some details, but the full picture remains hidden. We're essentially flying blind toward the most important destination in our galaxy's future, with no clear understanding of what awaits us there. Some cosmologists have proposed that the Great Attractor and dark flow might be evidence of interactions with parallel universes or dimensions beyond our own. If our universe is part of a larger multiverse structure, the Great Attractor could represent a point where our reality intersects with or is influenced by adjacent universes. This theory suggests that the massive gravitational effects we observe aren't caused by matter within our universe, but by the gravitational influence of structures in neighboring cosmic realms. We might be being pulled toward a cosmic boundary where the laws of physics, as we understand them, break down completely. While this idea remains highly speculative, it offers a potential explanation for why the Great Attractor appears to be so much more massive than the visible matter in its region can account for. If it's drawing gravitational influence from parallel realities, it could have effects far beyond what we can observe or measure within our own universe. The Great Attractor represents more than just a gravitational anomaly. It's a window into the ultimate fate of our universe. The cosmic flows and structures we observe today are shaping the universe's long-term evolution, determining which galaxies will merge, which star systems will survive, and how matter will be distributed across cosmic timescales. Understanding the Great Attractor is crucial for predicting humanity's long-term cosmic future. If our galaxy's trajectory toward this gravitational giant is inevitable, it will fundamentally alter the night sky, the distribution of nearby galaxies, and potentially the stability of our solar system billions of years from now. The Great Attractor stands as one of the most profound mysteries in modern astronomy, an invisible cosmic monster that's quietly orchestrating the movement of our entire galactic neighborhood. This gravitational leviathan, hidden behind the dust and stars of our own galaxy, represents a force so powerful that it's reshaping the architecture of the local universe. What's most terrifying about the Great Attractor is not just its immense size or gravitational power, but the fact that we're helplessly caught in its influence. Every second, our galaxy moves 400 kilometers closer to this cosmic destination, following a trajectory that was set in motion billions of years ago and cannot be altered by any known force. The discovery of dark flow makes the situation even more ominous. If the Great Attractor itself is being pulled towards something even larger and more mysterious beyond the edge of observable space, then our cosmic journey might be just the first stage of an even grander and more terrifying voyage toward the unknown. Perhaps most disturbing is the realization that we're traveling blind toward our galactic destiny. The Zone of Avoidance prevents us from clearly seeing what lies ahead, leaving us to navigate by gravitational shadows and cosmic inference. We're passengers on a galactic ship heading toward a destination that might be our salvation or our doom, and we have no way of knowing which until we arrive. The Great Attractor forces us to confront the ultimate powerlessness of our species in the face of cosmic forces. Despite all our technology and scientific knowledge, we remain completely subject to gravitational influences that operate on scales beyond our comprehension or control. We like to think we understand the universe, but the Great Attractor reminds us that we're still cosmic children, swept along by forces we can barely detect, let alone influence. The most profound implication of the Great Attractor is that it reveals the universe as a dynamic, interconnected system where nothing exists in isolation. Our galaxy's fate is tied to cosmic structures spanning hundreds of millions of light years, and our ultimate destination was determined by events that occurred when the universe was young and the cosmic web was first taking shape. In the end, the Great Attractor represents both our cosmic destiny and our cosmic humility. It's a reminder that no matter how advanced we become, we remain part of a vast cosmic dance choreographed by forces that dwarf our imagination. The invisible monster that's pulling our galaxy through space isn't evil or malevolent. It's simply the natural consequence of gravity operating on the largest possible scales. The Great Attractor is calling, and whether we like it or not, we're answering that call with every passing second. Our cosmic journey toward this gravitational giant has already begun, and there's no turning back. If this cosmic revelation about our galaxy's terrifying destiny has absolutely blown your mind, obliterate that like button. And if you're someone who craves these mind-expanding discoveries about the universe's most profound mysteries, subscribe immediately so we can continue exploring the cosmos together. Does the idea of being pulled toward an invisible cosmic monster terrify you? Do you think we'll ever be able to see what's really at the center of the Great Attractor? What do you think will happen when our galaxy finally reaches its destination?